I'm going to prove that you can achieve a lot of things just by using a simple Postgres database. No need for message brokers or complicated logic within your app. Now it's a bold statement, and we're going to try to replicate an e-commerce store with its usual use cases, such as asynchronously sending confirmation emails, delivery updates, as well as optimizing the database for data storage, as well as performant queries. Now, we're going to learn all of these interesting features that Postgres gives us out of the box, and not that many developers know about them. Now, when it comes to the database instance itself, we're going to be using Render's Postgres solution, which is a world-class, fully managed option with private networking, high availability, point-in-time recovery, read replicas, and other enterprise-scale features. So if you're ready to learn all of that useful and interesting stuff, buckle up and let's get started. And for the record, this video is sponsored by my friends at Render, but more on that later. So we're going to be deploying a Node.js Express application alongside our Postgres database so that they can talk to each other. And this index.js is very simple. I literally put all of the controllers and endpoints into one file so that it's easy for us to follow, and we're going to go over all of that. But in the beginning, I just want to point out that we're using PG, which is a library for Node.js, so that we can talk to Postgres database, and we're initializing a client where we're going to supply a database URL, and I'm going to add it as an environment variable during the deployment in a minute. Apart from that, we have commands.sql, and this is basically all of the commands that you need to run on your database, which I've already done beforehand to populate our database so that we can work with it right away. What we have here is basically creating ORD tables, types, and so on. We're going to talk about that in a minute. So let's go over to Render. And as you can see, I already have my Postgres database running, as well as a PG admin so that we can see some data in the UI. And I'm going to go and click Add New to create our Node API. I'm going to select Web Service. By the way, Render gives a lot of options. You can also create a static site, cron jobs, background worker, Postgres, key value, which is Redis, and all of this is managed, which is pretty much covering every stage of your full stack application. So we're going to go to web service. I'm going to select my GitHub repository called YouTube tutorials. I'm going to call it e-commerce API, e-commerce shop API. I already have a suggestion here. I'm going to select the language, which is Node, and I'm going to select my branch called Postgres is all you need, where all this code that we saw here resides already, because it's going to pick up this code and deploy automatically. A build command, I'm going to say npm install, and instead of a yarn start, I'm going to do npm start, as simple as that. I already tried a free tier, so I'm going to go with a starter this time. And also when it comes to environment variables, I'm going to do database URL. And as a database URL, I'm going to put the connection string that I have for my Postgres database. And now let's deploy the web service. While this is being deployed, I think it's a good time to tell you a little bit about Render itself. Render itself, as I said, is a full stack application hosting platform, which is unique. And the reason it's unique is because you probably already noticed it's very, very simple to use. You can literally deploy an application within a couple of clicks or within a single minute, as I did. So you can basically select the type of the thing or service that you want to deploy. You can even use Docker containers, and you can specify the commands, as I did, and it's basically going to listen for the changes in your GitHub repository and deploy automatically every time you push some code into your GitHub repository. So it's basically have a CI or continuous integration built into itself. All right. When it comes to languages and frameworks, it supports pretty much every major language, such as Elixir, PHP, Node, whatever you have there, as well as some front-end frameworks. Also, let's talk about enterprise-grade data stores, meaning you will have full support of your database. For example, if you choose a Postgres database, you know that you have 100% reliability and your data is never gonna get lost. Also, let's talk about all of these things that we are expecting from a modern full stack application nowadays, which is load balancing and auto scaling. This is already baked into Render. Also, infrastructure as a code. If you want to scaffold your backend automatically through code such as Terraform, but in render, we're using blueprints files. Also, DDoS protection and data privacy, again, baked into render. So this is pretty much something that early stage startups and even mid-sized companies would use if you guys don't want to spend time and resources on creating very over-engineered and sophisticated backends that nobody going to use, but instead you want to ship a product, iterate over very fast, and make sure that someone, such as render, takes care of your backend and frontend when it comes to full stack applications. All right, we're gonna see some other features as well, but to finish my sentence, we also have some preview environments, meaning you can deploy your application on staging or testing environments before production, as well as role-based access for each different employee or developer within your team. Now let's go back to render and see that our application has already been deployed. So the service is live, and we're going to be using this URL to basically hit our endpoint. Now, let's actually try to learn some of the features that we discussed before. And with that said, we're going to start with a real-time pops up with listen notify that's within the Postgres world. Now, this feature is kind of unique-ish, all right? So MySQL can do that, but it doesn't have native support, so you have to hack it in a way. But MongoDB, well, it's a different world. So MongoDB has change streams. So you can basically subscribe to some kind of a stream and then listen for changes. But Postgres can do it out of the box. The way it's going to do it is it's going to listen to every insert. So every time something is inserted into, for example, our order database, the Node.js application is listening, and the database is going to notify this listener so that we can send the data over automatically. For example, when a new order has been inserted into the database, we want to automatically send a confirmation email. And the way this is going to be done is with the help of functions and triggers. Basically, we're going to tell our function that, hey, send this message on a specific channel that our Node.js app is listening to. And the trigger is going to listen for events on the database itself. So trigger is going to say every time you have an insert, the trigger should run this function. And this is how it's going to work. Let's go over to the code and try to understand how this is looking like. So basically, we are having this command called listen, and it's listening on this channel. This is the channel name. And within the SQL commands in our orders table, we can see that we're creating a new function called notify new order, and begin end is basically the boundaries of the operation that this function has to do. So we're saying perform pg notify, and this is a built-in function of Postgres. It accepts a channel name called new order channel, the same channel that our Node.js is listening to, and it accepts a payload as the second argument. And a payload is gonna, first of all, take new. New stands for a new row that has been inserted. It's gonna convert it to a JSON format, and pg notify actually needs a string, so we're gonna convert it back to a string so that we can work with it. And also, this is a trigger that runs the function. So the trigger is gonna be called trigger new order, and we're gonna say after insert on orders table, for each row, we're gonna execute this function. As simple as that. And then we have this endpoint called create order. I'm gonna use it now in a second. And as soon as this is hit, we're gonna insert something into our orders database. And then we have an event listener on the client called notification. So on each notification, we're gonna take the order that the channel gives us and receive it and send out an email. Now, if we want to use this API, we have to actually copy the endpoint, go to our client that I have here, and actually I'm going to do a search and replace like this. So I'm going to replace it with the new endpoint, because every time you deploy the application, it gets a new endpoint. I'm going to save this, and I'm going to run this request. Let's say user ID 1, amount 3, and I want 3 electric guitars. So electric, like this. Oh, I think I missed the endpoints itself. So the endpoint is here, create order, and I'm going to add this at the very end, and let's try it again. And we can see that our new order has been received and we sent out an email. So basically, without adding boilerplate code to your Node.js application, you can automatically kind of outsource it to a database, meaning we don't need any polling. We can get real-time updates from Postgres itself. No need for Redis or RabbitMQ or any event-driven architecture, because Postgres does this, listens to events itself, and it's great for live feeds and any kind of dashboard. Now let's talk about role level security, or RLS, which is kind of unique-ish as well. So MySQL doesn't have RLS, but you can emulate it with views. Again, feels a bit hacky. SQL Server does, but it's not as advanced as in Postgres. So Postgres is kind of cool when it comes to that. So what is a role level security? Well, let's imagine we are logging into our application, and then we make an update order. So we want to update the order, and we already have the user ID that wants to update their order. But every time we have a multi-tenant application, also have a video on that, we want to make sure that the user that's trying to modify this entry has the same user ID, because they can accidentally modify someone else's order. And to do that, we always have to make sure that we add this condition, which is tenant ID, or we can call it user ID, is equal to the current user ID. So in other words, this user ID has to be equal to the user ID that's assigned to a specific order. And to do that, you don't need to add this condition anymore. We can do this automatically with role level security. And what does it do? It's basically, as I said, add this clause to every request in a session. It enforces security on a database level, meaning if someone bypasses your API, they're still not able to modify your database that easily. It's great for multi-tenant ads, but the super users can actually bypass RLS. Nevertheless, let's go over to our index.js, and we're going to see that here we have a login endpoint. And every time we log in, we take the user ID from the body, and we're going to run this command called set, and then you give it a variable name. In my case, I namespaced it called app.currentUserID. You can also leave this app out, but I'm going to leave it inside app.currentUserID, and you assign this user ID to the app.currentUserID. And now, as soon as it's enabled, every time you make a request, every time this request, for example, when you select something from the orders table, it's going to automatically look like this with an appended where clause. All right. So let's take a look at our command, the way you would enable it. This is pretty simple. Alter table orders enable a role level security, and you would normally attach a policy to it. This is the name of the policy on orders table, and we're going to say using user ID current setting app current user ID, and app current user ID is the variable that we defined in our API. So every time the login endpoint is hit, this is going to add a strict check for this specific call. How cool is that? So let's try to simulate that. We're going to go to our client and run an endpoint, a request to this endpoint, and we get 200 OK. Let's take a look at our logs on the API, and we're going to see that RLS enabled per user with current ID 1. It's great. The next feature we're going to talk about is called advisory logs. And this one is quite rare. I'm actually not sure which databases are able to do that, but let me know in the comments if you know. So advisory logs is basically a manual log, not an automated one. Let's first try to understand what kind of logs we have. So locking is basically a mechanism that locks your database and doesn't let someone or something to modify your database or a specific table or a row at this particular time. So for example, when you do an update on the users table, Postgres is going to automatically implement or do a row level lock on user ID 5. So no one else can modify the user ID 5 at the same time to avoid inconsistencies. Also, when you're altering the table users and you want to add some column, the Postgres database is automatically going to lock this table. And when you're inserting something into the orders table, again, another row level lock is going to happen. But we also have manual locks, such as advisory locks. So advisory locks are basically locks like this. So let's say 2 email workers are trying to pick up some orders and send an update for the delivery status of this order. And we have scaled because we have many orders, so we have 2 workers that are doing this at the same time. And every time one of the workers is trying to modify one of the entries in the database, it's going to use an advisory lock. And it's going to take the order ID as a lock ID. So we're going to take 34, meaning if this worker has done an advisory lock, another worker is not going to be able to do that. Now, how is it different from an automatic lock that we just discussed before? Well, the thing is, the worker beforehand agrees on a specific item that's gonna lock upon without modifying the table first. Because here we saw that we actually do some kind of an operation like update, alter, insert, but advisory lock doesn't have to do those to be able to lock something. So in this table, we can see that we can lock by arbitrary things, such as if you're running job runners, you can lock by a job name or a cron hash. If you have webhooks, you can lock by a webhook ID. If you have payments, you can lock by a cart ID, user IP ID, or business resource ID. Basically, it gives you flexibility over what you want to lock upon. And we also have different types of advisory locks. Even though this is quite advanced, I just want you to remember that we have blocking types and non-blocking types. Blocking types are going to wait until the block is released, but non-blocking types are just going to try, and if it's locked, it's going to return. If it's not, it can lock and do some operation for you. And we have XACT. This stands for a transaction. So transactions can also do advisory locks, and they're going to be auto-released when the transaction ends. So this is kind of handy. Now, let's take a look at the code and try to understand how this works. So there are no commands for doing locking that we have in our commands SQL. Instead, we're going to have this endpoint called prepare email that's going to send out emails with the shipping status. And the way you lock it is simply let's say in our case, it's going to be order ID. We're going to be locking by order ID. And we, first of all, do this select PG try advisory lock. And what $1 stands for the lock key, which is our order ID, as locked. And if it's not locked, it means the order is being processed currently. If we did acquire a lock, meaning now the order ID that a user sent us has been locked, it means we can proceed. And basically, we're going to change the order status of the specific order, and we're going to return 200 as soon as it's been marked as paid. As simple as that. Now, let's go over to the client and say prepare email for order 1. We're going to send the request, and let's see what happens. In the meantime, I can go to render already and see if we have locks, and we do. So locked order processing, order already paid. So we didn't have to mark it as paid because it was already paid. Let's try order ID number 2, send a request, and let's see what we get here in the logs. So locked order and order marked as paid. As simple as that. With that, you can make sure that your workers are never going to have a conflict with each other. So as a summary, advisory locks give you custom keys, basically arbitrary keys that you can lock upon, global coordination, and locks that can persist for the lifetime of the connection until you release them. Now let's talk about custom data types and composite types. This one is my favorite one. So sometimes you have an ID and home address of a customer, but home address can consist of multiple things. So multiple things meaning street, city, or a zip code, for example. And the way you can use custom data types within Postgres is very simple. You're going to declare an address like this, and it's going to be your custom type. So in the code, it would look something like this. So we're going to create type address as street text, city text, and zip text, and we're going to attach it to the users table simply like this. This is called a custom data type. And every time you retrieve data from it, it's going to come back as a string. Now, if you add an array here at the end, that's going to be a composite type, meaning you can add actually multiple addresses to a specific row. But in this example, we're going to leave this out. So it's going to be as simple as that. And again, this is another example for an array of composite types. Now, the thing that distinguishes Postgres from others, because others can also do it. For example, in MySQL, it's limited. In SQL Service, not that great of a support. SQLite doesn't have it. Composite types, MySQL doesn't even have composite types. Let me know your opinion. I think Postgres is the best for this. And let's take a look at our code. So every time we try to retrieve the address of a specific user, like here, we're going to get the user ID and we're going to select the home address from a user. Now, the home address is going to come home like this. Home address, and it's going to be one big string. Unfortunately, we have to parse it. We're going to parse it with the help of this library called pgtypes. And it's kind of necessary every time you work with complex types within Postgres, but it's going to help us. And we're going to split it by a comma, because as you can see, we have commas between every section. And then we can say that home address is this. Now let's try this. And we're going to send a request for our first user, and we got 200. And let's check our logs on render. And we're going to see that home address is 123 Main Street, Berlin, blah, blah, blah. So why is it good? It basically cleans up your database and lets you add composite types or custom data types every time you want to make your notation cleaner. So every time you know that you're not going to have too many manipulations on a specific custom key, because you don't have to divide them by columns every time, but you can just put them into one long string. You can actually use custom data types. And this is not limited only to addresses. You can implement it in many other things. Now, I want to quickly talk about the ecosystem. This is very exciting. Not many databases, actually, I don't know any other database that has such capabilities as Postgres. Basically, you can install extensions on Postgres very easily, and there are tons of them. You can do time-based partitioning, you can work with geospatial data, query performance analysis, fuzzy text matching, key value store basically eliminates the need for Redis, for example. Also UID generation, crypto, and time series data optimization. No need for InfluxDB or something like this. Postgres does this with the help of these extensions. Let me know in the comments if you have a favorite extension that I didn't mention them, because there are more than hundreds of extensions, but I just listed the ones that I've heard of and the ones that I know. And last but not least, let's talk about JSONB and indexing. So not that many people know, but you can actually store JSON in Postgres. Actually, some of the database can do that too. For example, MySQL can do that, but the querying is a bit weaker than in Postgres, and indexing is not as great as in Postgres. Obviously, MongoDB is a document-based database, so it does it out of the box, but it still does it better than others. Oh, I have a typo here. So what is JSONB? Let's go to the code and try to understand this. So I inserted these two users, Alice and Juan, into our users table, and I declared, actually this is how you add custom types, by the way. I declared two settings. So these are the settings, and they are basically a JSON form in a JSON format. Okay. The thing is, JSON format is very flexible, meaning if, for example, Alice doesn't have a theme, you can leave this out and it's still going to work. So you don't have that many restrictions. Now, it's also a bad practice to do too much nesting on JSON formats, but JSONB, JSON binary, is basically a very optimized way of querying such things. For example, when it comes to settings. Now, you can have thousands or millions of users, right? You can have a lot of data, and sometimes you need to query all of that, okay? So JSONB is basically going to look like this. Let's say we're trying to get a user with a particular theme. So we're gonna say we fetch from users where settings is theme equals like this. So you get the idea. You can put a lot of things into JSON and have like polymorphic structures within your Postgres, But this is not all. Let's talk about the fact that you can index them to make it even faster. So you can have a generalized inverted index every time you're looking for a specific pair. So you can say, I'm going to add a generalized index, and this add or higher sign basically checks if the JSON contains specific key value pair. This is the one that you would mostly use. Also, we have expression indexes, meaning we can extract the value of the theme key as text. So we can index on the theme. So every time we're looking for a dark theme, this is going to come as an answer, but much faster because the dark theme is now indexed. Or we can also do partial indexes where, or rather this one was targeting the theme, so the key, and this is the opposite where this is targeting the theme name, dark. So I mix those up, and this is the partial index. As you see, it's not only very flexible, but Postgres also gives you a lot of ways to optimize your JSONB formats. And this is basically great for a lot of polymorphic structures, as I said. Now, guys, if you learned something new in this video, make sure, first of all, to check out Render because they are great and you can deploy your website within seconds, especially if you're a startup that needs to iterate and build products very quickly. Check out the description. There are going to be links for you to get started. And smash like and subscribe to my channel for more videos like this. And I'm wishing you a great rest of the day. Goodbye.